Hey guys, Rohan this side and welcome to my YouTube channel. Let's start today's problem of the day on Geeksforgeeks. So today's problem of the day is scrambled string. Okay, so what exactly they are given? They just give us a one string and another string as s2, which is this some different characters of the string 1, but in the different order. So we need to check the s2 is the scrambled of the s1, but why and when we can say that s2 is the scrambled, there are certain rules. Okay, so what they are saying, what is scrambled string? So given string str, we can represent it as a binary tree by partitioning into the two non-empty substring recursively. Okay, so for string str is given coder coder, so this we can divide into coder and then at the end cod and er and at the end er. Okay, so what is the scramble? To scramble the string, we may choose a non-leaf node and swap its two children. Suppose we choose the node co and swap the two children, then it is oc and the remaining is the same, the remaining is der. Okay, either the another thing is we just take der and swap the two children's d and er. Okay, then we get re and d, the reverse thing. We just swap for er, then re and again der, then red. This is the, so this is called the scramble of the original string coder. But if we are just doing d c o er, no, that is not the scrambled. Scrambled is we can just swap two non-leaf childrens of two non-leaf nodes. Okay, so same, they are giving us the code coder and ocder, and we need to check like this is the scramble, s2 is the scrambled of s1 or not. Okay, so how we will check? We'll just take one by one all the characters and compare with the s2 for the remaining things. Okay, so if we are taking the first character, then we are just checking like what is the prefix and what is the suffix, and the same what is the for s2 also, what is the prefix and what is the suffix. Okay, it might possible they are scrambling the first node itself, so we are also checking the first index and the suffix, and the same way the last index of s2 and the prefix, this also we can match. Okay, so what all the things will match here, I already write here in the code. Okay, but before going to the code, let's first understand in detail. Okay, first this is coder and coder. Okay, then we are just checking for the node 1. Okay, so we are just getting c and from s2 it's o. Okay, but here what we are getting, it is like we have string length is 1. Okay, so if we have a string length 1, then we can give a true, but here the both the s1 and s2 string length is 1 and the different character, so it is definitely false. Okay, then we'll just come to the next i2. Okay, then for i2 we are checking that then pointer should be the prefix should be co, and for the s2 prefix should be oc. Okay, then co and oc, then we are again checking and the suffix for der and der. But if the s2 and s2 and s1 strings are same, then we can say that this is the scrambled, there is a no swap, that's why this is true only. Okay, and if we are checking for co and oc, we can say yeah, it's clearly swap of like c to o and o to c, so this is also scrambled. So for i2 we are just getting the two things true, and okay, and we are just written that, then we can say that coder and ocder, this two, like the s2 string is scrambled of s1. Okay, this is just a simple easy example I am explaining here. Okay, apart from that, let's go for the code. So the, as I say, we are just matching prefix and suffix, the same I am just right here in the code. Okay, so first what we are checking like s1 is equal to s2. If the both the strings are same, then it's just simply we can give true. Okay, and for the remaining we just start from 1 to the length of the s1. Okay, and we are just checking here we are just checking the prefix of s1 and s2, and if the prefix is also same and the suffix is also same, then we can go into the this if loop and we are just returning true. Okay, so we are here we are using the recursion, so that's why the same here here we just see that co, then again we'll check for all the index c and o, and here o and c. Okay, so that's why we are using a recursion here. So this type of dynamic problem questions are easy with the recursion, so we can solve this with the less number of code lines. Okay, and the same here, I am just checking, like here prefix with the suffix of s2. This is suffix is nothing but the this is minus I to previous things, right? So it's just taking the r and the previous thing, so it is also the what we can say, prefix of the last digit, and here it is, we can say that the suffix of the prefix of the first digit. Okay, so and we are giving this 2 into the again the scrambled, and we will just check it, like what result we are getting. And the same, the another condition is also same, suffix and the length of s2. So what is the length of s2 here? We can say it is like 5 minus I. So if we are taking at the 2, then 3. Okay, then we'll just take it like 3, and we'll just check the first 3 things and compare here with 3 here with the last 3 things. As I say I is equal to 3, then 3 to last, then we'll get the last 2 things, and here the first 2 things. So what is in the first if loop? Prefix of s1 compared with prefix of s2, and suffix of s1 compared with suffix of s2. Okay, and if both the conditions satisfy, then we can return true. And in the second if loop, not a loop but second if condition, what is this? The prefix of s1 with the suffix of s2, and the suffix of s2 with the prefix of s1. Okay, and if both the conditions satisfy, then we can return the true here. Okay, I return in this code I write a multiple print statement just to understand how this code works. So here you could see, like for the I we are getting like CODER and OCRED. Here the input is bit different. Okay, then as we said, this will not return true because the first character these are checking, and these are 2 different things. Okay, then it's come to 2. Okay, then if it's come to 2, then there will be a 2 part, as I say, CODER and OCRED. Here the s2 string is different, and here we are just take the DER, but here is RED. Okay, and now it just take the 2 things, like it's first checking for CO and OC, and other way it's checking for DER and RED. Okay, and the remaining things are, we can see here, CC is same, then true, OO is same, then it's true. Okay, then here we are checking DER and RED. Again it's just split into the 2 things, ER and RE. Okay, then here we can say, okay, EE is same, this is just a swap, RR is same, and this is the first prefix, and the suffix for S1 and S2 is same, then DD is the same. Okay, so the same at the end we can say that the DER and RED, like RED is the scrambled of DER, so this is also true. This CO and OC is also true. So if true both the time we are getting true, then we'll just at the end we'll get the true for this CODER and OCRED, and at the end we can say we just return yes here. Okay, and if none of these conditions satisfy, then we can simply return the false. Okay, so let's compile this code, and we could see yes. Okay, the first test case satisfies fine. Okay, one more thing, here we use this LRU catch is equal to none. This is this decorator. Okay, why we are using this? Okay, the reason is, if we are doing this much recursive things, okay, then there will be some cache clearance things, like they can store up to 128 bit, and after that they just clear the cache. But here we just said that no need to clear the cache, so that's why we just get all the recursion. If this is just a file, the length of string is just 5, but when we are getting more number of what we can say long string, then there will be a more cache we need to store to get all the result from this recursion. So that's why we just mention here LRU is equal LRU cache none. Okay, so the first test case satisfies fine. Now let's just submit it for all the test cases, and 164 test cases, all the test cases satisfies fine within the time limit, and we could see, okay, this is the solution for today's problem of the day. And thanks for watching this video. Stick to my YouTube channel for all the learnings and everyday's POTD on GFG. And yeah, thank you guys. Like, share and subscribe to my YouTube channel. Thanks.